All right, guys, we'll go ahead and get into this next section of notes here for Unit 6. This is going to be 6.4, and we are talking about right triangle congruence today. So date that we're going to do this is either the 24th or the 25th, depending on what class period you have. And our objective for today is we're adding in another theorem. So we're talking about proving that triangles are congruent. And specifically, we have one more theorem to kind of add in here. We've talked about 4 so far. This is going to be the 5th and final theorem that we can use here. So this theorem is what we call the HL theorem. And when I said this, I said that we're doing, this is called right triangle congruence. So this only works with right triangles. And if we think about the pieces of a right triangle, two of the pieces of a right triangle are what we call the hypotenuse and the leg. So this is the hypotenuse leg theorem, and it says this. It says if, one leg and the hypotenuse, one leg and the hypotenuse of one right triangle are congruent to one leg and the hypotenuse of another right triangle, okay, so I look at this here. I say if one leg and the hypotenuse of one right triangle are congruent to one leg and the hypotenuse of another right triangle, then I can say my same conclusion that we always do, which is the triangles are congruent. So we have another theorem that we can now add into the mix, and specifically working with right triangles. So for example here, what am I looking to show, or what should this look like in a diagram? If I draw this here, as a reminder, a right triangle is a triangle with one right angle. Let me try to draw that second one a little better. There we go, a little better. Do the same thing here. I want to make sure this is as close to a right angle as we can get. So right here, right angle, right angle. Remember, if we're thinking back to Unit 5, we talked about right triangles, and we said a leg, or the legs of a right triangle, are the two sides that make up the right angle. So for instance, here and here would be the two legs. And then the hypotenuse is always this third side, this long side that's across from the right angle. So what this is saying is if I have one pair of legs, so let's just choose, doesn't matter which pair we choose. So for instance, the leg on the left, and then the hypotenuse of each triangle. So for example, whoop, and there goes the triangle. I'll draw this back in. Okay, and then the hypotenuse of each triangle. If I see this, and I can show this, then we can say that these two triangles are congruent. And notice how this is actually a little bit shorter than some of the other theorems that we've had, because usually we need 3 pieces of information, varying between sides and angles. In this case, we only need 2. We need 2 pairs of sides. And the reason for that is because we'd already know by the Pythagorean theorem, if 2 of the sides were congruent, then that pair of third sides would also have to be congruent. So this is kind of just a way of using the side theorem, except I can kind of skip one step because it is a right triangle, okay? So let's practice this a little bit and kind of see if we could spot this example in different diagrams here. So I want you to take a sec for example 1 and just sketch these triangles for me. Okay, and then once we have these sketched, we're going to look at this and we're going to answer this question. It says it wants us to determine if the following triangles are congruent, and then if so, name the theorem. So first pair of triangles I'm looking at right here, I see these and I'm asking the question, would I be able to show that these are congruent, or are these triangles congruent? And the answer, if I'm looking at this, is yes, I do have enough information. And then the question is, what theorem would this match? Well, notice here it's not going to be hypotenuse leg like we just mentioned, because I don't have the hypotenuse of either one of the triangles. Okay, I have a pair of legs, but I don't have the hypotenuse of either one of them. So it's not going to be that one, but if I look at what I am given, I see I have one pair of angles that I know are going to be congruent, because they're both right angles, or they're both 90. I have another pair right here, so that's 2 pairs of angles, and then I also have one pair of sides. Okay, so I have 2 pairs of angles, 1 pair of sides, and then the last thing here, this pair of sides is in between the 2 angles, so this would be the angle side angle theorem. So notice this can still be used, or other theorems can still be used if I see a right angle. We can still use the same theorems and still apply those when we're looking at these different diagrams here. Okay, so that's the first one. Moving on to the next pair here, I see these triangles as well. They also have right angles in them. And the question is, do I have enough information? Well, notice I don't have a hypotenuse or a leg, and in fact, I don't have any of the sides. I just have 3 pairs of angles. And unfortunately, even though this is a lot of information, 3 pairs of angles, or angle, 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 is not one of the theorems that we've talked about. So I would say no, not enough information. Just because the angles of triangles are the same does not necessarily mean they're going to be congruent. The side lengths could be different. Okay, so that would be no. Triangles are not congruent. All right, and then lastly here, if I'm looking at this one, I see I'm given some information, so I still have right angles here, and you can sketch this if you'd like. Same question as before, would I be able to show that these are congruent? Well, notice I do have a pair of legs that I know are congruent, and then the question is, do I have the hypotenuse of each triangle? Well, yes, we've talked about this idea before. If there's a shared side, then I know it's going to be congruent to itself, and I know that just by looking at it. So since that is the case, and since I have all this information, this would be yes. These 2 triangles would be congruent, and then what would the theorem be that matches this? This is an example of the HL theorem. They are right triangles. I have 1 pair of legs, and then I have the hypotenuse of each triangle as well. Okay, so just being able to spot those is just good little skills that we want to develop as we work through these kinds of problems here. All right, moving on. As we've seen many times in this unit, this is very proof heavy, so we want to make sure we understand how to use this in a proof. Okay, so I'm going to go ahead, sketch my picture here, and then once you're done sketching the picture, you can go ahead and set up your proof with statements and reasons. If you need to pause your video to do all that, feel free to do so. Okay, so if I'm looking at this here, I know where to start on all these proofs. I'm just going to start with my given information, so I'm not going to overthink this too much. Just given here. And I'm told a couple things. I'm told CE is perpendicular to BD. Remember, this is the perpendicular symbol. And then I'm also told that BE is congruent to DE here. Okay, so no overthinking on the first step. I just copied on the information and write in given. So if I'm looking at this here, one other thing or one other tip that I like to throw in to make sure that we understand is anytime that I've said that angles or sides are congruent, I'm going to go ahead and mark that on my diagram. So in my given, I'm told that BE is congruent to DE, so I'll go ahead and mark that. And now we're going to start working through this proof, and the process is still the same. We're going to ask ourselves those 2 questions. First question is, what do I know from my given information? Well, like I said here, we said CE is perpendicular to BD. Okay, so that's in our given, and we can use that information. If I say that these 2 lines are perpendicular, what does that tell me about them? Remember, we've said that if 2 lines are perpendicular, and we said this back in semester 1, if 2 lines are perpendicular, then they create 90-degree angles, or in other words, right angles when they intersect. And so these 2 angles right here at this spot, BCE and DCE, are going to be right angles. And so that's all I'm going to say. I'm not going to say that they're congruent. I'm literally just going to state the fact that angle BCE and angle DCE are right angles. So anytime I see that something is 2 lines are parallel, this should always be my first step. Just state the fact that they're right angles. And how do I know that, or what's my reason for that? That's just what it means for 2 lines to be perpendicular. So I'm going to say definition of perpendicular lines. If 2 lines are perpendicular, they create 90-degree angles. Okay, why is this helpful, or why do we say this? Why are we not thinking about how they're congruent or they're the same? Because we don't need to know that they're congruent, or we don't ever need to state that. Remember, if we're dealing with the hypotenuse leg theorem, the only thing that I said with this is this only works with right triangles. So if this theorem only works with right triangles, what that means is somewhere in my proof, whether it's in the given or whether I show that in a statement later, somewhere in my proof I have to say that these are right triangles. And so this is why this statement is helpful, because I can say if these 2 angles are right angles, which they are, then that means those 2 triangles are right triangles just by definition. So now my next statement is I'm going to say triangle BCE and triangle DCE are right triangles. These 2 triangles are right triangles. And like I mentioned, the reason for this is the definition of a right triangle. If it has 1 right angle in it, then it's a right triangle. So definition of right triangle. If you're going to use the hypotenuse leg theorem, this needs to be one of your steps. You have to say somewhere in there that they are right triangles. Now that I have this, now I can use this and just need to make sure I have the hypotenuse and the leg. Okay, so I do have the hypotenuse of each triangle. That was something I was given. And then to find the leg of each triangle that we know are congruent, I always ask myself that second question. What do I know from my diagram? Well, if I'm looking at this diagram here, go ahead and erase these. If I'm looking at my diagram, remember, we know the shared side of two triangles is always going to be congruent to itself. So I see this side here, CE. So I can say CE is congruent to CE. We've seen this idea many times before. Anytime there's a shared side, I can always say it's congruent to itself. And my reason for that, we need to make sure we memorize. Anytime I say something's congruent to itself, that's what we call the reflexive property. Okay, and I'll go ahead and mark that as well. CE is congruent to itself. Okay, now I've said somewhere in my proof that these are right triangles. I have the hypotenuse of each triangle. I have a leg of each triangle. So I can say my last statement here. I can say triangle BEC is congruent to triangle DEC. And I'm just copying that down from the proof statement. And then what is my reason for that? Well, remember, if we say that these are right triangles, it almost leads us always to one theorem, and that would be the hypotenuse leg theorem. Okay, so notice it's still kind of three pieces of information. You need the hypotenuse, the leg, and then the only other thing you need to make sure to say somewhere is that those are right triangles that you're looking at. Okay, but that's how you work through some of those kinds of proofs. Okay, another example here, last one for today. If you'd like to, you can pause your video and sketch this diagram, and then once you're done doing that, you can go ahead and set up your proof with statements and reasons here. Move this over here. Okay, I'm not going to worry about looking at how to work through this proof just yet. I know I just want to get the basics down, so I'm just going to get my first statement here, given. And then what do I know? Well, I'm told AB is perpendicular to BC. I'm also told DC is perpendicular to BC. And then I'm told CA is congruent, to BD. So I'm not thinking about what any of these pieces of information tell me just yet. I'm just writing them down, just copying them down. Okay. Like we've mentioned before, good habit to get into. If you say that sides or angles are congruent, I would go ahead and mark that on your diagram. So we're told these two lines here, CA and BD, are congruent. So I'll go ahead and mark those each with a dash mark, dash mark, and dash mark. Okay. And now we're going to start to work through this proof, and we're going to do the same thing as before. So if I'm looking through this, I'm trying to figure out what information do I know here. Always start with that first question. What do I know from the given? So we said AB is perpendicular to BC here. And remember, if that's the case, remember two perpendicular lines intersect at a 90-degree angle. So I know this angle that I just accidentally drew out is now a right angle. So I'm going to say angle ABC. And then before I finish that statement, I also notice the same idea over here. DC and BC are also perpendicular. I guess I'll include all of those here. Okay, so this angle that I just drew out, angle BCD, both of those angles are going to be right angles. And what's our reason for that, or how did we know that? Same idea as the last proof. This came from the fact that these were perpendicular lines. So I'm going to say definition of perpendicular lines. Definition of perpendicular lines. Okay, always need to include this piece here if I'm told that two lines are perpendicular. Okay, and I'll go ahead and mark that as well. They're both right angles, so I'll go ahead and say this is a right angle. This is a right angle as well. Okay, and then what can we use this for, or how can we go from here? Remember, if we're going to use the hypotenuse leg theorem, after we say that they're right angles, I need to say that the triangles are right triangles. So now I'm going to follow up this statement the same as before and say triangle ABC and triangle BCD are right triangles. I'm still not worrying about what sides or what angles are congruent. All I'm doing is just following this kind of process that I see here, starting with my given. Okay, so these two triangles are right triangles, and how did I know that? Same as before. This is just the definition of a right triangle. The definition of a right triangle says if it has one right angle in it, then that has to be a right triangle. Okay, so we've answered the first question. What do I know from my given? We've gotten to that piece where we've said these two triangles are right triangles, which is helpful. We're going to need that. And then the second question we always need to ask, is what do I know from my diagram? Okay, and this one's a little bit more difficult because remember, we're looking for basically one of two choices, either a shared side between the two or vertical angles. And if I'm looking at this here, notice I have the hypotenuse of each of my right triangles, and I just need a leg of each of them. Well, we see here, just by looking at the diagram, there is a shared side. It's just a little bit more confusing than usual because it's overlapping each other. And this shared side that's in both these triangles is actually the side on the bottom, BC. And so what I can say here is I can say BC is congruent to, and this is one of those unique situations where when I see it written up at the top here, BC, that actually corresponds to CB. So notice when I say this statement, I actually need to change the order around for the second one. And it'd be the same way as if I were to flip the triangles around to make them match. BC would line up with CB. So if we don't know when to do that, always look at your congruence statement up here, because that should tell you which letters should line up with each other, BC and CB. Okay, the good news is the reason's still the same. We've said that two things are congruent, or the same thing is congruent to itself, so this is reflexive property. Good property to memorize here. And I'll go ahead and mark that on the diagram as well. Another pair of sides that I know are congruent. And notice it's a leg of each of the right triangles. So I have this information here. I've answered those two questions. What do I know from my given? What do I know from my diagram? And in this case, I do have enough information to say my final statement. Triangle ABC is congruent to triangle DCB. Okay, I do have enough information to say that. And what is my reason here, or what am I going to put? What theorem does this match? Well, notice I've said that these triangles are right triangles. I've got the hypotenuse of each triangle, and I've got a leg of each triangle, so this does match the hypotenuse leg theorem. Okay, we don't have any other theorems with right triangles, so if you've said somewhere that you have a right angle or a right triangle, it's a fairly good bet that hypotenuse leg is going to be the one that you use. Okay, so just keep that in mind as you're working through those problems. Okay, so that is all we have today for the notes. The assignment that goes with this today is the 6.4 exit ticket, so just make sure to get that from me or get that online and get that done and turned in. And as always, if you guys have any questions, feel free to let me know. All right, thanks guys.